In this example, we're asked to solve the triangle in figure 9. And typically, when we're asked to solve a triangle, it means that we're supposed to find all of the unknown values, all of the values that are labeled with a variable. So in this case, it says that we're supposed to find b, alpha, and beta. And that's because b, alpha, and beta are the three unknown values in the triangle. We can start by finding side b. It's a side of the triangle, and we're given the two other sides. So a nice way to approach this would be to use the Pythagorean theorem. Use Pythagoras. And Pythagoras tells us that the sum of the squares of the two shorter sides of the triangle equals the square of the longer side, the hypotenuse. So we can use this to solve for b. So first I can square both 7 and 10, and then I can isolate b squared by subtracting 49 from both sides. 100 minus 49 is 51, and then we're going to have to square root that. Let's do that a little nicer to isolate b. And so here we can see what b equals. All right, so now we're left to find the angles alpha and beta. If we were to go and kind of stand at the triangle, in the triangle right here at angle alpha, and look into the triangle, we could notice that the side labeled 7 is opposite this angle, and the side labeled 10 is opposite the 90-degree angle, and sides opposite 90-degree angles are always called the hypotenuse. They're always going to be the longest side in our triangle. Now these two values, the hypotenuse and the side opposite angle A, are given on the triangle. They're given in the problem. They have to be correct. It's possible that we may have made a mistake here finding B. Hopefully we didn't. I don't think we did, but if you do math yourself, you know it's possible you make some kind of mistake, and then if you use that result to find other values, you might be compounding mistake on top of mistake. So if you're ever able to use kind of the typed given information in the problem, that's often a sensible choice, and in this case, we do have the side opposite alpha, and we have the hypotenuse on the triangle, and we know that the sine of an angle in a triangle, in this case like the sine of the angle alpha, is defined to be the side opposite the angle divided by the hypotenuse of the triangle. And these are those two values that were given. And so we know the hypotenuse is 7. The side opposite alpha is 7 and the hypotenuse is 10. So we know that the sine of alpha is 7/10. And then we can find alpha by using the sine inverse function, applying that to both sides to isolate alpha, and then we're left with the sine inverse of 7/10. We need some sort of calculator to approximate that. That's not something we would be expected to know for ourselves, so I've opened up Wolfram Alpha here to do the calculation. If I do arc sine is a little easier to type for the inverse function of 7 divided by 10. You can see it's already trying to give me the value of 0.77. It's likely to want to give me a radian value, so I might try to force it to give me some values in degrees, which are more natural when we're working with triangles to use degrees. So we can scroll down and see that the value looks like it's about 44.43 degrees. So this value of alpha is approximately 44.43 degrees. Alright, so now we have alpha. And the only remaining value is beta. And we could use a trigonometric function to find beta, similar to how we just found alpha. But now that we know alpha, and we know one of the angles is 90 degrees, we know two of the three angles, and we should be able to find the third angle using the 180 degree rule. So recall that the sum of the angles, so alpha plus beta plus the 90 degree angle, the sum of all of the angles in the triangle must be 180 degrees. Okay, so now we can solve for beta by substituting our known value for alpha. So I'll put alpha in here, 44.43 degrees. Add that to beta and to 90 degrees, and we expect the result to be 180 degrees. Now we can go ahead and isolate beta. Beta will be approximately 180 degrees minus 90 degrees minus 44.43 degrees. I just noticed I put a 4, well there should have been a 3. And now we could go ask Wolfram Alpha again to do this calculation. 180 minus 90 minus 44.43, and we get 45.57. So beta is approximately 45.57 degrees. And this is our third angle. And now we found the 3 unknown values in the given triangle.